Here we're given a system of nonlinear equations and we need to solve each system. So as you can see, what makes it nonlinear is because you have the power of x here that is not 1, it's precisely 2, and the power of x here is 3, and the same thing in the second system. Okay? Now, nonlinear system means that sometimes one may be a linear and sometimes one may be quadratic, or it could be both. Quadratic, one of them is a cubic, as you can see here. So it's going to be usually a mix of linear or nonlinear or a mix of nonlinear in one system. So here, how do we solve this? In order to solve this, first we have to solve for the y. So the best thing to do is to solve for y each line provided. So that means if you divide both sides by 2 in the first equation, you will get x squared over 2. If you divide by 4 the second equation, you will get y is equal to x to the third divided by 4. Okay? So now you know that when you have a solution, you're talking about the graphs of each of these two equations having an intersection point, a meeting point, or a common x, y point, right? The common coordinate. So when you set the y's being equal and you solve for x's, you will have found that way two coordinates, or at least two coordinates at which the graphs of these two equations meet. Now keep in mind that in this example we'll also find imaginary solutions or complex solutions. Not just real solutions but also imaginary ones. So the first thing you do is to set the y's being equal. So you mean x squared over 2 is equal to x to the third divided by 4. Okay? Now the next thing you do, you subtract x to the third over 4 on both sides, from both sides, and you're going to get x squared over 2 minus x to the third over 4 is equal to 0. And now what you want to do, you want to multiply both sides by 4. Okay, you want to multiply both sides by 4. Basically the equation by 4. Both sides of the equation by 4. And you will get something like this. 4 over 2 is 2, so 2x squared. 4 divided by 4 is 1, so it's just minus x to the third. And 0 times 4 is still 0. And now what you want to do, you want to factor out the x squared for these two terms, so you will get this. X squared is outside, so you're going to get 2 minus x is equal to 0. Okay, this is how you factor the left side. So now individual factors can be set to 0 and therefore are solvable. So x squared is equal to 0, and in another case 2 minus x is equal to 0. Okay? So what we get here is x is equal to 0. Now x is equal to 2 if you add x on both sides. You would get x is equal to 2, right? So the second x value is 2. So that means the solutions are given as coordinates. So you found the x values and you need to also find the y values, right? When x is equal to 0, we're going to check the first x value we found. Y is equal to, now notice that you can plug into any y and you will get the same thing because it's a common meeting point. When it's a common meeting point or an intersection point, you can plug the x into any of these two original equations and you will find your respective y value that will be the same y value. So I'm just going to plug it in the first equation. So 0 squared over 2 is still 0, so that means it's 0 for the y. And the second solution, when x is equal to 2, we're going to check it in here. 2 squared is 4. 4 divided by 2 is 2. Now, in case if you wondered, if you plug in 2 here, you will get the same thing. 2 to the third is 8. 8 divided by 4 is 2. So as you can see, you get the same exact y value no matter which equation you plug your x into. Alright, so these are the respective solutions. As you can see, all the solutions are real here. There are no imaginary solutions. None containing the I, the imaginary number. Now in this case, we will have imaginary solutions. So how do you approach this problem? you solve for x, the second equation. As you can see, the x is already given in terms of y squared. You don't touch that, but the second equation, you do solve for x squared. Okay, and what you get as a result is x squared is equal to 2 plus y squared. Now I'm going to copy down the first equation that was given, x is equal to y squared. So now, as you can see, you still have to take the square root on both sides, right? Because you have to solve for x to the first power, just like you see in the first equation, because right now it's squared, right? So if you square root both sides, you will get x is equal to plus minus square root of 2 plus y squared. Okay, and I'm going to copy the first equation. We get this, right? So now you can set the x's equal, because you know that intersection points means the x's are the same and the y's are the same. So you set the x's equal and then solve for the y values, and whatever the y values you get, you will use that for the respective x values. So now what do you do? What do you do after this? Well, notice that you will set the results for the x equal, right? So you're doing y squared is equal to plus minus square root of 2 plus y squared. You might say, I'm kind of confused. Where do I go from here? How do I solve for y? Well, notice that we need to get rid of the square root, right? We need to get rid of the square root, so we need to square both sides so that the square root is gone. Because if you square the square root, you get the inside and the square root is gone. And notice that the plus and minus will also go away when you square, because when you square the minus, it becomes a plus. When you square the plus, it stays plus, right? So you get rid of the minus anyway. And now squaring the left side gives you y to the fourth, right? Because squaring the y squared means that the square that 2 will multiply the original 2 there, so it will become a 4. So y to the fourth is equal to this being squared, right? This thing being squared. So what that means is that y to the fourth will equal just 2 plus y squared. You see, now it became a lot easier. Now you subtract the 2 and you subtract the y squared so that you will have a 0 on the right side. So as a result, you will get this, y to the fourth minus y squared minus 2 is equal to 0. Now this is an easily recognizable form in the equation that you can factor on the left side. You can factor it as y squared minus 2 times y squared plus 1, right? Because you need factors of -2, which are -2 and 1, that also add up to -1, the coefficient of the y squared. And in fact, they do. -2 plus 1 is -1, the coefficient of the y squared, right? Now, notice that we can set each of these factors to 0, respectively, right? So let's do that. So y squared minus 2 is equal to 0, in which case y, if you add 2 on both sides, y squared will be equal to 2. If you square root both sides, you will get y is equal to plus minus radical 2. Okay, so 2 solutions that will be possible with this. Now in the second case, here's where the imaginary part comes in. So y squared plus 1 is equal to 0. If you subtract 1 on both sides, you will get y squared is equal to -1. And this will give you an imaginary solution, because if you square root, you can't square root the -1, right? Otherwise, it's not going to be a real number anymore. So whenever it's not a real number, it's going to be an imaginary number, an imaginary respective solution, right? So square rooting both sides gives you plus minus square root of -1, which means plus minus I, right? Because square root of -1 is equal to I, the imaginary number. So here's the deal. You have 2 real solutions with that y, and you have 2 imaginary solutions with this y. So how do you write them up? So solutions. So let's list the solutions that we have. Okay, and I'm going to indicate them with this color. So we have what? We have plus minus radical 2. So let's test radical 2 first. So when y is equal to radical 2, let's plug this y radical 2 in here. You square the radical 2, right? Because y is squared here. Squared radical 2 just gives you positive 2. When you square the negative radical 2, right, for the second y solution, negative radical 2, when you square that, you still get positive 2 for the x, right, because it's squared. The negative squared is still positive, right, so it's 2. Okay, and notice that these are real solutions. These are real. Now the imaginary, I will list the imaginary now. So the imaginary, let's go ahead and write that. So imaginary solutions, plus minus I, right? So let's plug in positive I in here. When you plug in the positive I, you're basically squaring the square root of -1, right? Because I is this, square root of -1. If you square that, you will get the inside, right? -1. When we have I, when we plug in I here, you will get -1. Okay, and the solution, the second one is minus I. Now minus I means basically minus in front of the square root, and inside the square root is -1, right? Minus I is equal to minus square root of -1. So if you plug this in to the first equation, you're going to square this whole thing, and the minus will become a plus, and the square root will be gone. So the only thing that remains is inside the -1, right? So whenever y is negative I, you will also get -1 for the x. Okay, so the imaginary solutions are -1 comma I and -1 comma -I. So I hope this was a lot of fun. Thank you for watching, and I'll see you in the next video.